solving systems using substitution. So if we were given two equations, a system of equations such as y equals 2x minus 4 and y equals x minus 3. Instead of graphing this on your xy coordinate plane, you can solve using a different method. And we could solve this one using substitution. So what you have to notice here is that your y is solved for in both of your equations. So I could take this y and what it equals. It says y equals x minus 3. And I could substitute that x minus 3 in for the other equation y. And I could have done vice versa. I could have taken this 2x minus 4 and substituted in for the y in my second equation. Either way, we would have written x minus 3 equaling 2x minus 4. Because I'm substituting the x minus 3 in for y because that is what y equals. I then am going to solve for x. So I would subtract x from each side, leaving me negative 3 equals 2x minus 1x, so 1x, minus 4. I add 4, and I get that 1 is x. So here I have my x-coordinate. My x-coordinate is 1. To find the y-coordinate, we're going to take this 1 and substitute it into either equation. So y equals, we could say, 2 times 1 minus 4. So instead of 2x minus 4, I have x is 1. So y is 2 minus 4. Y is negative 2. So here, my ordered pair, which is the solution to the system. So if I was to graph y equals 2x minus 4 and y equals x minus 3, I would see that they would intersect the point of intersection 1, negative 2, which is then called my solution to the problem. Let's look at another example. Let's look at an example if I had 2x minus 3y equaling 10 and y equals negative 5x plus 8. Now my first equation is not solved for y or x. It's in what we call standard form. Now my second equation is solved for y. So I'm going to take this expression and plug it in for y. I would do the same if I had an equation solved for x. I would take the expression and plug it in for the x, but here it's for y. So I would write then 2x minus 3, not y, the quantity, negative 5x plus 8 equals 10. Because it was 2x minus 3y, and now I'm saying y is negative 5x plus 8. I then will solve by distributing. Remember, always take the sign in front. So positive 15x minus 24 equals 10. Combine like terms because they're on the same side. So 2x plus 15x is 17x. And then I could, in the same motion here, add 24 to both sides. So 17x is 34. I divide by the 17, and my x-coordinate here is positive 2. And just like before, that's going to be the x-coordinate. To find the y-coordinate, I'm going to plug in. And I could plug into either. I'm going to plug into my second equation here. Negative 5 times positive 2 plus 8. So my y-coordinate, negative 5 times 2 is negative 10 plus 8. Here, I'm going to get negative 2. So my solution here will be 2, the x-coordinate, negative 2, the y-coordinate. So again, if I was to graph these two equations, they would have their point of intersection at 2, negative 2. Let's take a look at if I had parallel lines. What would happen then? So if I had an equation such as y equals negative 2x plus 3 and y equals negative 2x minus 4. Now they have the same slope, so we would have parallel lines. If I was to set this up using substitution and I take this expression and plug it in, I would get negative 2x minus 4 equals negative 2x plus 3. And I would add my 2x as normal, but here my variable eliminates, and you get negative 4 equals 3, or if you added the 4, you would have gotten 0 equals 7. And that's false. That's not a true statement. So here, we would get the no solution situation because we would know, hey, these are parallel lines, and parallel lines never intersect. So there's no solution. So algebraically, when this happens, you get this false statement. Negative 4 does not equal 3. 0 does not equal 7. So if you're solving substitution and they happen to be parallel lines, you are going to eliminate the variable, you're going to get a false solution, and it'll be no solution. If they were the same line, this would be identical, and then we would say infinite amount of solutions.